First of all, what is flora? Well, flora refers to the plants that grow in a specific area and the publication or scientific descriptions of those plants. When referring to a publication, the word is frequently capitalized to distinguish between the two. A flora can range from a simple list of plants found in a specific location to a very extensive description of those species. Floras differ from popular manuals is that they seek to cover all plants rather than just the most common or visible.
So now, in this section, we will be talking about the plants and biogeochemical cycles. According to Britannica, biogeochemical cycles are any of the natural pathways by which essential elements of living matter are circulated. The term biogeochemical is a contraction that refers to the consideration of the biological, geological, and chemical aspect of each cycle. There are 6 main biogeochemical cycles: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Plants recycle matter in biogeochemical cycles. For example, through transpiration, plants move enormous amounts of water from the soil to the atmosphere. Plants such as peas host bacteria that fix nitrogen. This makes nitrogen available to all plants, which pass it on to the consumers. Plants take up nitrogen compounds through the roots. Animals obtain these compounds when they eat the plants. When plants and animals die, or when animals excrete waste, the nitrogen compounds and organic matter re-enter the soil. Next, plants absorb sulfur when it is dissolved in water. Animals consume these plants so that they take up enough sulfur to maintain their health. Most of the Earth's sulfur is tied up in rocks and salts or buried deep in the ocean in oceanic sediments. Next section, we will be talking about the main cycles under flora, which are nitrogen and sulfur cycles.
The nitrogen cycle. Nitrogen is necessary for all life forms. It is a crucial element of the amino acids found in protein and nucleic acid building blocks. Humans, plants, and animals cannot directly absorb nitrogen from the air. As a result, it is transformed through a process known as the nitrogen cycle. The cycle starts with nitrogen fixation, which converts the nitrogen in the atmosphere into ammonia. Next is the ammonia will be assimilated by living organisms. When these organisms die and decay, bacteria or fungi will convert the nitrogen into ammonium. It will then be converted into nitrites and nitrates through nitrification. Lastly, the nitrogen will go back to the atmosphere with the help of denitrifying bacteria. The sulfur cycle. Sulfur in many forms circulates throughout nature. Sulfur is contained in all living organisms as an amino acid component. It is common in soil proteins and becomes sulfates that plants can utilize after a series of microbial changes. The ocean will release dimethyl sulfide into the atmosphere, which will then be converted into sulfur dioxide. Same with volcanoes, but from hydrogen sulfide through volcanism. Factories are also going to release sulfur dioxide. It will return back to Earth by raining down sulfuric acid and sulfates and will be assimilated into living organisms. And when those organisms die and decompose, it will eventually make its way back to the water supply and back into the ocean as sulfur. Alternatively, it can be made into fossil fuels through the rock cycle and will be used by factories, and the cycle continues.
Epigenetics of plants. What are epigenetics of plants? Over the past several decades, epigenetic modification in gene expression have captivated the scientists. These processes have drawn a lot of attention in plants because they can produce stunning differences in noticeable traits like coloration. Changes in the expression of stress-responsive genes in plants that enable adaptation to varied pressure are caused by epigenetic control based on histone modification and DNA methylation. Memory-based defensive responses of priming kind are regulated by such epigenetics factors.
What is invasive species? Any non-native species that damage the local ecosystem is considered an invasive species. These non-native plants and animals outcompete and drive out species that have developed specifically to exist in our local ecosystem when they become established there. Non-native species are not always invasive. A species must be easily adaptable for it to be invasive. It needs to multiply swiftly. It must cause damage to real estate, the local economy, or the local wildlife and plant life.
An impact on the nitrogen cycle and sulfur cycle causes negative ecological effects. The nitrogen cycle is the biochemical cycle responsible for citing nitrogen among plants, animals, and the abiotic factor of their environment. The process is a natural component of entire Earth system. Like most biochemical cycles, human activities are capable of altering the natural conditions of the nitrogen cycle. The two activities that are primarily responsible for this alteration are the use of fossil fuels and the addition of nitrogen to fertilizer. These activities have served to increase the amount of nitrogen biologically available in the environment.
Human activities have a major effect on the global sulfur cycle. The burning of coal, natural gas, and other fossil fuels has greatly increased the amount of sulfur in the atmosphere and ocean, and depleted the sedimentary rock sink. Humans greatly influence the phosphorus cycle through the release of mined phosphates into ecosystems, especially in the form of fertilizers, but also from detergents and sewage waste.
Ways to reduce human impact on the nitrogen and sulfur cycle. To help restore and lessen our impact on our planet's nitrogen and sulfur cycle, we must find ways on how to fix the wrongdoings that we have put upon our world. First we have is the ways on how to lessen our impact on the nitrogen cycle. Our first recommendation is to reduce our daily food waste. Our second recommendation is to use organic products rather than processed products. Our last recommendation is to use fewer pollutants. Next, what are ways on how to lessen our impact on the sulfur cycle? The first recommendation is to increase the use of clean and renewable energy. Second is to reduce our carbon footprint. Lastly is to use new sources of energy like solar energy, wind energy, hydropower, and so much more.